Assalamualaikum warahmatullahi wabarakatuh. Hello, we are from Group H and we will explain about Three-Way ANOVA. Okay, first, my name is Dini Hasanatunisa. I will explain a definition about Three-Way ANOVA. Definition. What is the Three-Way ANOVA? The Three-Way ANOVA is used by statisticians to determine whether there is a three-way relationship among variable on an outcome. It determines what effect, if any, three factors had on an outcome. Three-way ANOVAs are useful for gaining an understanding of complex interaction where more than one variable might influence the result and have many applications in science, social science, and medical research, among a host of other fields. A three-way ANOVA is also known as three factors ANOVA. By using ANOVA, a researcher is able to determine whether the variability of the outcomes is due to chance or to the factors in the analysis. The three-way ANOVA is used to determine if there is an interaction effect between three independent variables on a continuous dependent variable. As such, it extends the two-way ANOVA, which is used to determine if such an interaction exists between just two independent variables, rather than three independent variables. A three-way ANOVA can be used in a number of situations. For example, you might be interested in the effect of two different types of exercise programs for improving marathon running performance. However, you are concerned that the effect that each type of exercise program has on marathon running performance might be different for males and females, as well as if you are normal weight or obsessed. In that, you suspect that the effect of the type exercise program on marathon running performance will depend on both your gender and body composition. As such, you want to determine if a three-way interaction effect exists between type of exercise program, gender, and body composition. In explaining marathon running performance, ANOVA was used to find out all the independent variables and to determine the effect of the independent variables on the interaction variables. Some of the requirements that must be met in a three-way ANOVA test
is normality test. Data normality test is a prerequisite test of data that is suitable for analysis using statistic or non-parametric statistic. Through this test, a research result can know the shape of the distribution of the data, which is normally or not normally distributed. The simplest normally test is to graph the distribution above the existing score, but if the amount of data is large enough and the distribution is not 100% normal or abnormal, then the conclusion drawn may be wrong. To avoid this error, it was corrected using the Kolmogorov-Smirnov test. The hypothesis for the data normality test using the one sample Kolmogorov-Smirnov test is as follows. The sample comes from the population with the same creation background, normally distributed data. Sample from population with different creation background, data not normally distributed. Furthermore, the significant level and the MAC value were compared with the table. The criterion The criterion for testing the hypothesis is that HU is a captured if or then the data is normally distributed. The next is homogeneity. Test homogeneity examination is used to determine whether the variance of the treatment is homogeneous or not. Homogeneity test was carried out by lavender test. HO is captured if the statistical significance for less than the test significance. The level of significance of the test used is 0.005, so that is a captured option less than 0.005. In this quick start guide, we show you how to carry out a three-way ANOVA using SPSS statistics as well as interpret and report the result from this test. However, before we introduce you to this procedure, you need to understand the difference assumption that your data must meet in order for a three-way ANOVA to give you a valid result. We discuss this assumption next. Okay, next is assumption. When you choose to analyze your data using a three-way ANOVA, part of the process involves checking to make sure that the data you want to analyze can actually be analyzed using a three-way ANOVA. You need to do this because it is only appropriate to use a three-way ANOVA if your data faces assumptions that are required for a three-way ANOVA to give you a valid result. In practice, checking for this assumption means that you have a few more procedures to run wrong in SPSS statistics when performing your analysis, as well as spend a little bit more time thinking about your data, but it is not a difficult task. Assumption 1. Your dependent variables should be measured at the continuous level. It is an interval or ratio variable. Example of continuous variables include revision time, measured in heart, intelligence, measured using AQ score, exam performance, measured from 0 to 100, wings, measured in kilogram, and so forth. You can learn more about interval and ratio variables in your article, Type of variable. Assumption 2. Your three independent variables, so each consists of two or more category independent group. Example, independent variable that meet this criterion include gender, two groups, male or female, ethnicity, three groups, Caucasian, African American, and Hispanic. Profession, 5 groups, surgeon, doctor, nurse, dentist, traffic, and so forth.
Next, assumption 3. You should have independence of observation, which means that there is no relationship between the observation in each group or between the group themselves. For example, there must be different participants in each group with no participant being in more than one group. This is more of a study design issue than something you will test for, but it is an important assumption of the three-way ANOVA. If your study fails this assumption, you will need to use another statistical test instead of the three-way ANOVA, a repeat measure design. If you are unsure whether your study meets this assumption, you can use our statistical test selector, which is part of our enhanced guides. Assumption 4. There should be no significant outliers. Outliers are data points within your data that do not follow the usual pattern, e.g. in a study of 100 student IQ score, where the mean score was 108 with only a small variation between students. One student had a score of 156, which is very unusual and might even put her in the top 1% of IQ score globally. The problem with outliers is that they can have a negative effect on the three-way ANOVA, reducing the accuracy of your result. Fortunately, when using SPSS statistic to run a three-way ANOVA on your data, you can easily detect possible outliers. In our enhanced three-way ANOVA guide, we A. show you how to detect outliers using SPSS statistic, and B. discuss some of the options you have in order to deal with outliers. Assumption 5. Your dependent variable should be approximately normally distributed for its combination of the group of the three independent variables. Whilst this sounds a little tricky, it is easily tested for using SPSS statistic. Also, when we talk about the three-way ANOVA only requiring approximately normal data, this is because it is quite robust to violation of normality, meaning the assumption can be a little violate and still provide valid result. You can test for normality using the Shapiro-Wilk test of normality, which is easily tested for using SPSS statistic. In addition to showing you how to do this in our enhanced three-way ANOVA guide, we also explain what you can do if your data fails this assumption. It fails it more than a little bit. Assumption 6. There needs to be homogeneity of variance for each combination of the group of the three independent variables. Again, while this sounds a little tricky, you can easily test this assumption in SPSS statistic using 11 tests for homogeneity of variance. In our enhanced three-way ANOVA guide, we A. show you how to perform 11 tests for homogeneity of variance in SPSS statistic. B. explain how to interpret the result of this test. And C. present possible ways to continue with your analysis if your data fails to meet this assumption. Next, you can check assumption 4, 5, and 6 using SPSS statistic. Before doing this, you should make sure that your data meets assumption 1, 2, and 3. Although you don't need SPSS statistic to do this, just remember that if you do not run the statistical test on this assumption correctly, the result you get when running a three-way ANOVA might not be valid. That's all we can say about three-way ANOVA. If there is a wrong word, please forgive. Thank you for watching and see you!